Good morning everyone. Welcome to today's GATE session. Myself Saranya in the Department of Artificial Intelligence at SA Engineering College. Today we are going to discuss about the topic name is Multilayer Perceptron and second one is Feed Forward Neural Network. Before we enter into this topic, we have to come to know the looking into the agenda. What is machine learning, types of machine learning, multi-layer perceptron, feed-forward neural network, forward and back propagation example, and finally we will discuss about the GATE question. This is the basics about machine learning. So machine learning is a branch of artificial intelligence to understand the computer from the past data, then it will be taking the decision based on the past experience. Let us consider the real-time example, that is Amazon recommendation. Once you enter into the app Amazon, it will shows you the past data so that we can able to add the destination about the past data experience. It is called machine learning. So it learns from your past viewing data to make the better prediction about what you might like next. Next, types of machine learning. First one is supervised learning. This model is based on the labeled data. We have both data. One is input and another one is output. Next, here two types. One is classification and another one is regression. Classification is nothing but output is categorical. Example, you have whether it is the data is spammed or not spammed. Next one is regression. Regression is the output continuous. So example is the house price prediction. An example of supervised learning is first one is linear regression and next one is logistic regression. Next type is unsupervised learning, where the model is trained using the unlabeled data. So here have only inputs, not the output. Here also we used two types. First one is clustering and second one is association. Clustering is the group of similar data and association is the finding the relationship between the two data. Example of unsupervised learning is K-means and hierarchical clustering. Third one is reinforcement learning. So here where the agent is learns by interacting with the environment and receiving the reward. Here we have to follow some components like agent, environment, reward and action. So example of reinforcement is Q learning and deep Q network. Fourth one is self-supervised learning. So this is the model we can learn from the unlabeled data. It can create the data itself so that instead of humans, it's providing the labels and modify part of the input and predict the hidden or missing part, and finally it is learned from the patterns from the past process. So example is the model learns to predict the missing word. Next, what is MLP? MLP is a multi-layer perceptron. So multi-layer perceptron is a supervised learning. So it consists of the neurons. Where the neurons is used, weight, sum of inputs and bias, it will passes into the hidden layer and then finally will get the output from the output layer. So this is also called ANN. ANN is nothing but artificial neural network. Here we used three methods. One is input layer, second one is hidden layer, third one is output layer. Input layer receives the input data and hidden layer is perform the calculation or computation, and final one is output layer. Output layer it produce the final result. This is also called a feed forward network, which means data moves in the one direction, so that it's called feed forward neural network. This is the illustration of MLP. MLP, first we have multiple inputs we are giving into the multiple hidden layer. Here we are going to use sum of weight. After it is passes into the output layer based on the bias. Next one, perceptron is usually referred as the neuron and multi-layer perceptron is referred as the neural network. So MLP is capable learning complex and non-linear method. Here you can see the pattern by the multi-layer perceptron. Red dotted data, it is classified in the separated data, that is class 1, and green data, it will be stored in the separated class, that is class 0, and this purple line is called as model boundary. Next, key components of working of multi-layer perceptron. So first, multi-layer perceptron, it learns to mapping the input into the output based on the two methods. One is forward propagation, second one is backward propagation. Adjusting its weights and bias based on the error between the prediction value and the actual data. Here we have 6 components. First one is input layer. The process starts with input layer, which receives the input data. Each neuron in this layer is represent feature of the next layer. Next one is weighted connection and biases. Connection between the neurons, it is associated with the weights, and these are leading into the training process. Each neuron in the hidden and output layer has associated bias term, which allows for the fine tuning and then shifting for the activation function. Third one is activation function. Here we have to follow the two methods. One is sigmoid function, another one is RELU. RELU is nothing but rectified linear unit. Next, fourth one is forward propagation. So this process is starting from the input layer and it is passes into the output multiple layer, and then finally we go for output layer. This is the forward propagation. In each layer, the before mentioned steps here involved weight of sum of inputs and then biases and then finally activation function. Here is the forward propagation. First we have two input layer, one is x1 and another one is x2. Next, hidden layer. How to find the hidden layer? This is called Z1, this is Z2, and finally we'll get the output of Z3. Z1 is combination of x1 and x2 plus weight of the input value. So Z1 is equal to W11 into x1 plus W21 into x2. So this is the Z1, and you have to find a same like Z2 and then finally Z3. Next one is hidden layer. We have to see one single input layer which is communicate with the one hidden layer. So here we have the inputs and some of the weights, and finally it will be entered into the single hidden layer. After that we have to find the activation function. So f of z is the output of the activation function. Final layer, this is called the output layer. So the final layer is output layer. This layer is often uses the softmax function. So this is used to the tasks in multiple classification and also sigmoid function for the binary classification. For regression task, no activation function might be applied in the output layer. Next one is back propagation and learning. Once the forward process through the network which is completed, then the output is compared to the true value and then predicted value. The error is then propagated back through the next network, that is backward propagation, adjusting the weight and the bias value. Back propagation is typically done using the optimization algorithm. So here is the important algorithm, that is SGD, stochastic gradient and then descent and its variance value. Next, working of back propagation. Here two method is there. First one is forward pass and second one is backward pass. First we will see the forward pass. Forward pass, how it will work. The input data is fed into the input layer and then that input is combined with the respective weight. Then it will enter into the hidden layer. So example, here we have two hidden layer. One is H1 and another one is H2. H1 is combined with the weight of the W1, J. 1 is the ith position and J is jth position, which is connected into the input N1. N2 is also connected with the N2 and N3, which is connected into H2, and finally the combination of hidden layer, it will based on the bias value, finally it will produce the output, that is O. Next one is backward pass. In the backward pass, the error is between the predicted and actual output, which is propagated back through the network to adjust the weight value and then bias value. One common method to find the error calculation, that is MSE, which is called a mean square error. So we have to follow one formula, that is predicted output minus actual output whole square. Once the error is calculated, then the network adjusts weight using the gradient method. So gradient, which means it indicates how much each weight and bias value should be used. Based on that, it will be reduce the error for the next iteration. Now we can see one problem using forward propagation and then backward propagation. So first you have to assume one neuron. It uses the sigmoid function for the forward and backward pass. The target output is 0.5 and then learning rate is 1. Here two outputs, one is x1 and another one is x2. x1 value is 0.35 and x2 is 0.7. This is connected with the two input hidden layer, that is H1 now. So we have to find H1 node first. So that we have to multiply input value into weight value. We will see one by one. First one is initial calculation. So weighted sum at each node, calculating Aj, which is equal to sigma of W, Ij into Xi. Here Aj is weighted sum of all the input and Wij is represent weights between the I value and then J value, and finally Xi is only mentioned for the I value. O is the output. After applying the activation function, we have to find the output value, that is A. Next one is sigmoid function. The value between the 0 and 1. Formula is Yj, which is equal to 1 by 1 plus e power minus Aj. Here we have to find H1 node, H2 and then O3, that is Y3, Y4 and Y5 value we have to find. First, computing the output at H1 node. I already said in the previous slide how we can find the H1 value. We need to multiply X1 into weight of the input layer, 0.35 into 0.2. 0.2 into 0.35 plus weight of 2, 1. Here what is 2, 1 is 0.2. 0.2 into X2. X2 is 0.7. And finally we will get the value of A1. We have to find like that for H2. Before you need to apply in the sigmoid function. So Y3 is equal to F value is 0.21, A1 value. 0.21, 1 by 1 plus e power minus A1 is 0.21. You will get the value of Y3. This is nothing but output layer. Y3 value is 0.56. Next, you have to find the same method for the H2 value. So H2 is equal to A2. A2 is weight of 1, 2 into X1 plus weight of 2, 2 into X2. So 0.3 previous slide. Here W 1.2 is 0.3. So 0.3 into 0.35 plus 0.3 into 0.7. So you will get the A2 value, and after that you have to apply sigmoid function. Y4 value is 0.59, and the next one A3 value same like that, Y5 0.67. So Y3 value is now 0.57 and Y4 is 0.59, and O3 is the 0.67, it's also called Y5. Next, we have to find the error calculation. Our actual value is, I already mentioned in the problem itself, that is 0.5. But we get the predicted value is 0.67. What is 0.67? Here output layer is 0.67, but problem 0.5. So predicted value is greater than target value. So we need to find the back propagation. 0.5 is the problem value minus predicted value is 0.67. So we'll get minus 0.17. This is greater than the target value. So we have to find the back propagation. So back propagation, first one is delta Wij. This is changing the weight between the I and J value. Next eta. Eta is learning rate. Learning rate is default value is 1. And then delta of J is the error term of neuron J value. And finally OI is the output of neuron I value. Next, we have to find the gradient value and also find the unit error, that is delta. First step, we have to update the weight. This is the formula, delta Wij equal to neta into delta J into OI. Here the term already I discussed in the previous slide. Next, calculating the output unit error, that is delta. Delta is equal to y of 1 minus y into y target minus y. Here this part is called as y of 1 minus y is called a sigmoid function, and this part is called as target term. So first we have to substitute the given value. Y5 we already found, that is the 0.67 output layer value, and target y minus target value is 0.5, and y target minus y5 value is, target value we already mentioned in the problem, that is 0.5 minus predicted value is 0.67, you will get minus 0.17. You need to substitute in the delta 5, which is equal to y is what here, y value is 0.67 of 1 minus y is again what, 0.67, and y target minus y value we already found, that is minus 0.17. Here you have to mention, and finally you will get the value of delta 5. Next, formula for the hidden unit, that is delta. H is equal to YH of 1 minus YH summation of WH comma 0 into delta of 0. So this is, we have to going to find the hidden error. So sigmoid derived of hidden neuron into weighted sum of output error. Next, for hidden neuron we have to find the H1 node first. So we already have the given value is y3 is 0.56 and y13 is 0.3, and delta 5 value is minus 0.0376. So here is the formula I already mentioned. First we have to find the sigmoid derivation value. So 1 minus y3 is what here, 0.56, which is equal to, you will get the value of 0.44, and then y13 is what, 0.56 into 0. This value, you will get the value of 0.24 and 64. Next you have to multiply the weight and the output of the error. So 0.3, that is weight of 1, 3. 1, 3 is 0.3. So 0.3 into this value 0.376 is the delta 5, and finally you will get the value of 0.01128. You have to multiply this both value, you will get the value of delta 3. Next, for hidden neuron H2 node. So already we have the data, that is Y4 is 0.59 and weight of 2, 3 is 0.9, and next one is delta 5 value is minus 0.0376. You have to find the delta 4 value, so you need to use the formula Y4, 1 minus Y4 weight of 2, 3 into delta 5. First you have to find the sigmoid derivation, so that 1 minus Y4 is what? 0.59 which is equal to 0.141, and 0.59 into this value 0.41. Y4 is what here? 0.59 into this value is what? We recently found, no, 0.41. You need to multiply both value and you will get it the sigmoid function value. Next, multiply the weight and the error. So 0.9 is what? Weight of the 2, 3 is what? 0.9 into delta value is 0.0376, which is equal to, you will get the one answer. Next, you have to multiply this answer and this one, which is nothing but sigmoid function, and multiply the weight and error value. You will get the delta 4 value. Next, update the hidden value from the output weight. So given is eta is default value is 1, and then delta 3 is minus 0.0376, and O2 is the what? Hidden layer. This is 0.59 and old value of weight of 2, 3 is 0.9. So first you need to find the weight. Already we have the weight 2, 3 is 0.22184. Now we have to find the new weight of 2, 3 is 0.877816. So it is decreasing the error in the negative value. Next, step 3. Here similarly update all the other weights, then finally we will get the output of updated weights. W1, 2 is this value, and W13 like W21 and W22. So here is the final output, that is Y3 is 0.57 and H2 node, Y4 is 0.56 and O3, this is the output layer. Final output is Y5 0.67. This is the update value Y3, Y4 and Y5. Now you have to check the predicted value and actual value. So you need to find the error calculation, Y target minus Y5. Y target is 0.5 and Y5 values will found 0.61. 0.61 you will get minus 0.11. In previous section we'll find the minus 0.17 for the forward propagation. Now we will get minus 0.11 for the backward propagation. So it will be reduced. Your destination output is reached. So the termination is completed. Next, advantage of back propagation. The key benefit of using the back propagation algorithm, it is easy to implement, and simplicity and flexibility and also efficiency. Disadvantage and challenges of backward propagation: vanishing the gradient problem and then exploiting the gradients, and finally overfitting. Now we will discuss about some gate questions. First one, back propagation algorithm updates weights using Hebine rule and chain rule of differentiation, bias theorem and truth table. I already mentioned in the first slide itself. The back propagation algorithm is the chain rule of differentiation. Next, second one is in back propagation, the error signal propagates back propagation. So, the data moves from right side to left. So, you will get the output first, after that hidden layer, then you enter into the input layer. So, option B is the right answer. Third one, the derivation of sigmoid function. Sigma of x, what is the formula? We already used sigma x of 1 minus sigma x. So, option C is the correct answer. Next, fourth question. XOR gate is not solved by single layer perceptron because it is non-linear separable. I already mentioned activation function itself. This is based on the non-linear. So, answer is the option C, non-linearly separable. Next, hidden layer neuron helps to. Why we used a hidden layer? It is reduce the error. So, option is, this is based on the non-linear decision boundaries. I already mentioned in the previous slide that diagram, multi-layer perceptron. So, option is B, create the non-linear decision boundaries. Next, sixth one, convergence in back propagation is achieved when the convergence gradient value is achieved, it will be reduced the error. So, error is minimized. Option B is the right answer. What is the main purpose of back propagation in a neural network? It is used to update the weight using the error gradients. So, option B is the correct answer. Which of the following is the common optimizer used during the back propagation sensor flow? Here, SGD. This is the stochastic gradient descent method, and here we will use the two variables. From that we can find the common optimizer. Let us continue in the next gate session. Thank you.